Students, let us continue the next problem. I will read the question, please follow. So this problem is a somewhat lengthy problem. Kindly understand. I will explain step by step. A cylindrical vessel of 12 centimeter in diameter and 30 centimeter deep is filled with water up to the top. Okay. So a cylindrical vessel is there, cylindrical container, 12 centimeter in diameter and 30 centimeter depth is filled with water up to the top. The vessel is open at the top. Find the quantity of the liquid left in the vessel. Okay, quantity of the liquid left means what is the remaining water in the vessel. When it is rotated about its vertical axis with a speed 300 rpm and 600 rpm. Okay, so when the speed of the angular velocity, so that means the speed n value is 300 rpm means, so since the water level is up to the top, okay, so some of the water during that speed, some of the water will spill out. Okay, 300 mm and 600 mm speed, there are two different varieties of speed they given. Okay, so under this condition, what is the remaining water, quantity of the remaining water left in the container? So that is the question. Okay, so now write the given data. What is the diameter of the cylinder? It is 12 centimeter. Okay, radius is 12 by 2, 6 centimeter. Initial height of the water how much? 30 centimeter. Okay, so next speed. Speed is 300 and 600. So next, initial volume of the water. So the first step is to calculate the initial volume of the water. See, the container is there. This is the container. Okay, so water is up to this level. So this is the water. Okay, so what is the diameter? 12 centimeter, and height is 30 centimeter. Okay, 30 centimeter and 12 centimeter. Okay, so this is the given data. So initial volume, how to calculate initial volume? So for the cylindrical specimen, the volume formula area into h. Okay, so area pi by 4 into d square, it is 12 square, and h is how much? 30 centimeter height. Okay, so pi by 4 into d square into h. So pi by 4 into 12 square into h is 30 centimeter. So finally we get, here I am substituting all the values in terms of centimeter. So you can change into meter also. Okay, so finally the initial volume is 3392.9 centimeter cube. So this is the initial volume. Okay, so now here there are two speeds is given. Okay, let us see the first speed. So what is the first speed? So it is n is equal to 300 rpm. Okay, first speed n is 300 rpm. So under this category, what is the remaining water inside the cylinder? Let us check. So once speed is given, what is the angular velocity? Omega is equal to formula 2 pi n by 60. So 2 into pi into n is 300. Okay, it is given in the question. Divided by 60. So what is the answer? 31.41 radians per second. So this is the answer. So height of the parabola is given by z equal to omega square r square divided by 2g. Omega square r square divided by 2g. So omega is 31.41. So square r is 6 centimeter square divided by 2 into 9.81. So this is not 981, it is 9.81. Okay. So in terms of centimeter, it is 981. So here we are substituting all the values in terms of centimeter. Okay, so it is 981 only. In terms of meter, it is 9.81. Okay, so substitute 981 as it is. So finally we get an answer 18.10 centimeter. 18.10 centimeter. Okay, so this is the depth of the parabola. So this is the container, and This is the depth of the parabola. Okay, this is the parabolic shape, and this depth is z equal to 18.1. Okay, 18.1 centimeter. So as the vessel is initially full of water, okay, that also given in the question. Initially, the water level is up to the height. Okay, so water will be spilled if it is rotated. So automatically, if you rotate, means some of the water will be spilled out. Okay, so under this condition, volume of water spilled is equal to the volume of the paraboloid. Okay, please note down this assumption. So volume of the water spilled is equal to the equal volume of the paraboloid. So this paraboloid is formed. Okay, so this volume, okay, this volume which is equal to the water spilled out in the cylindrical specimen. So both the volumes are same. Okay, so but volume of the paraboloid. So now we will check the volume of the paraboloid. So how to check the volume of the paraboloid? Using the formula: area of cross section multiplied by height of the parabola divided by 2. So this is the formula. Okay, so this is the formula for volume of the paraboloid. First we have to calculate the area into z by 2. So pi by 4 into d square is the area, and z is the parabola divided by 2. So pi by 4 into what is d? D is 12 square. Multiply by z. Z is 18.1 centimeter divided by 2. So finally we get an answer 1023.53 centimeter cube. Okay, so this much amount of water is spilled out. Okay, so it will spilled out from the containers. Okay, so volume of the water left. So now what is the, see, since initially this is the volume, this is the initial volume. So this volume is spilled out, okay, outside the container due to the rotation. Now tell me what is the volume of the water left, balance volume of water in the container. So 3392.9 minus 1023.53. This is the volume of the water left. So initial volume minus volume of water spilled. So this is the answer. What is the answer? 2369.37 centimeter cube. So what is the unit of volume? So centimeter cube or meter cube or mm cube. So here we are substituting all the values in terms of centimeter. So centimeter cube. Okay. So this is the first problem. First category. So in case of speed is equal to 300 or RPM. So first what we have to do, first calculate the angular velocity. Based on the angular velocity, calculate the Z, depth of the parabola. So based on the depth of parabola, we have to calculate the how much amount of liquid or water is spilled out from the container. So using this formula, area of cross section into height of parabola divided by 2. Okay. So finally we get an answer 1023.53. So volume of the water left is initial volume minus volume of water spilled out. Okay. So next we will move to the speed is equal to 600 RPM. So now let us see, for 300 RPM, the depth of parabola is 18.1 centimeter. Okay, for 300 RPM, the depth of parabola is 18.1 centimeter. So again, I am increasing the speed. Okay, as in our video. Okay, in forced vortex video. So I am increase the speed means what happened? Automatically, the depth of parabola also increases. Okay, depth of parabola. So initially, this is for 300 RPM. For 600 RPM, it's like this. So depth of parabola will get increases. Let us see how much it is increases. Okay. So now n is equal to 600 RPM. Omega. Okay. So same step as in our previous case. Same step. 2 pi n by 60. 2 into pi into n is 600 divided by 60, which is equal to 62.82 radians per second. Okay, so this is the omega value. So next, we must calculate the height of parabola. Height of parabola. So what is the formula? Omega square r square divided by 2g. So omega 62.82 and r 6 and 2g 2 into 9.81. Now we got 72.4 centimeter. 72.4 centimeter. So actually the depth of the container is only 30 centimeter, but we got 72.4 centimeter. How it is possible? It is possible. Okay, so more number of water will spill out. Okay, so as the height of the parabola, so now imagine, so this is the actual container, but the parabola depth is this one. Okay, so this height is 72.4. so assume that this is the actual line of the parabola. So the container bottom is this B. Okay, so this line is an imaginary line. This line is the imaginary line. So initially the depth of the container is 70 centimeter, but due to this depth of parabola 72.4, so we have to imagine that container height is 72.4 centimeter. So this point from C O D is the imaginary line. Okay, it is not real, it is an imaginary. So balanced water left is only in this portion. You can see here it is like a triangle shape. Okay, so only this much. So we need to calculate what is the quantity of this water. Okay, this is the cross section. Okay, so now how to calculate? So as the height of parabola is more than the height of cylinder, the shape of imaginary parabola will be as shown in figure. This is the imaginary parabola from here to here. This is the imaginary parabola. Okay, now let r equal to radius of the parabola at the bottom of the vessel. Now you can see r. What is meant by r? It is the distance between center point of the container to the D point. This is called r, small r. Okay, radius of the parabola at the bottom of the vessel. Okay, next, height of imaginary parabola. Now what is the actual height of the imaginary parabola? So 72.4. So this is the actual depth of the parabola minus this 30 centimeter. So this is called, this line from C O D is the imaginary parabola. Height of the imaginary parabola is nothing but center point, that means bottommost point of the container to O. So how much? 72.4 minus 30. So that is the depth of the container, which is equal to 42.4 centimeter. 42.4 centimeter. Next, volume of water left in the vessel. Volume of water left in the vessel. So how to calculate this volume of the water left in the vessel? So using this formula. So volume of water in portion A, B, C and D, E, F. So you can see here, this is A, this is B and this is C. Take this triangle and this D, E, F. Since it is the circular one, imagine it is not an actual triangle, it is a circular portion only. So how to calculate this volume? So using this formula, initial volume of the water. So initial volume of the water we already found. Okay, minus volume of the paraboloid. That means volume of the paraboloid AOF. AOF. Okay, so initial volume minus this volume. Okay. Next, plus volume of the paraboloid COD. Volume of the paraboloid COD. So first, initially, this is the water. Full of water is there. This is the initial volume. So now again I minus this portion. Okay. So this volume is less than the whole, because the height is 72.4. Okay. So the initial volume will be less compared to the parabolic volume. Okay. Depth of the parabola volume. Okay. So for this condition, we get minus value. We get minus value, that is not the actual volume. So finally, we have to add volume of the paraboloid COD. So this is the volume of the paraboloid. So we have to put plus. Okay. So because this is an imaginary, this portion is an imaginary portion. We can't minus because this is an imaginary portion. We have to add. Okay. So finally we got an answer. So now initial volume we already know. That is previously we seen 3300 something. Okay. Now volume of the paraboloid AOF. Volume of the paraboloid AOF. That means this volume, whole volume from AOF. Okay. How to calculate? Using the formula pi by 4 into d square into height of parabola divided by 2. Here 2 is missing. Please note down. So pi by 4 into d square into height of parabola divided by 2. Okay. So next, substitute all the values. Pi by 4 into d. D is the diameter, is 12 square into what is the height of parabola? 72.4. So here square they given, it is wrong. Okay, it is not square, only 72.4 divided by 2. So finally we get an answer 4094.12. The students, here you can see actual volume, that means original volume is 3392 only, but you can see the depth of the parabola, sorry, volume of the parabola, full parabola is 4000. How it is possible? Because we are drawn the imaginary parabola. Okay, so now AOF is equal to 4094.12 centimeter cube. So this is the volume of the paraboloid AOF. Next, we have to calculate volume of paraboloid COD. Okay, so for the imaginary parabola COD, which is equal to omega 62.82 radians per second. So Z equal to 42.4 centimeter. This also we already calculated here. Okay. Next, R equal to radius of the bottom of the vessel. So omega also we already calculated previously, and Z also 42.4, and R equal to radius of the bottom of the vessel. Okay. So next, Z. So Z formula, what is the Z formula? Depth of the parabola omega square R square divided by 2G. Okay. So here we need to calculate this R. What is the amount of, that means the distance between center point of the cylinder to the D value, sorry, D point. Okay, so Z we already calculated 42.4 imaginary parabola depth, which is equal to omega is 62.82, and R keep as it is divided by 2 into 981. So this is the substitution value. So R square, so we need only R. Okay, substitute all the values. Finally, we get R is equal to 4.59 centimeter. 4.59 centimeter. This is the answer. So from this, calculate volume of the paraboloid COD. So what is the formula? So area at the top of the imaginary parabola, area of the imaginary parabola into height of parabola divided by 2. Okay. So first calculate area. So how to calculate area? Pi into R square is the area into height of parabola. What is the height of parabola? 42.4 divided by 2. So here 2 is given. Please don't write here. We follow same formula. Okay. So 42.4 divided by 2. So substitute all the values, pi by 2 into, sorry, pi into R square. R square is this one, 4.9. 4.59 square into 42.4 divided by 2. This is the answer. So finally we got 1403.89 centimeter cube. So this is the volume of the paraboloid. So now what is the formula? Volume of the water left is equal to initial volume minus volume of the full parabola. That means imaginary parabola plus volume of the parabola of COD. Okay, so you can see here. Okay, so here this formula: initial volume of water minus volume of parabola AOF plus volume of parabola COD. So this is the formula. So using this formula, finally we got an answer of 702.67. So this is the initial volume, and this is the volume of the full parabola, and this is the volume of the COD parabola. So from this volume of water left only 702.67 centimeter cube. Okay, so this question is 10-mark question. It is initially difficult to understand. Once you understand, it is very easy. Okay, now students. So I hope all of you understand this problem. Okay. So next we will move to the next topic. That means momentum equation. So this is the last topic in your second unit. So today we will complete this second unit and we will start the third unit. Okay, third unit is very easy only. So in this momentum equation there is no problem, only theory only. What is the momentum equation? So you know about Newton's second law of motion. What is Newton's second law of motion? Force is equal to mass into acceleration. Okay, this is the Newton's second law. Okay, so this momentum equation, it is based on the law of conservation of momentum or on the momentum principle, which states that the net force acting on your fluid mass, is equal to the change in momentum of flow per unit time in that direction. Okay, so the net force acting on your fluid mass, okay, is equal to the change in momentum of flow per unit time in that direction. Okay, so the force acting on your fluid mass m is given by Newton's second law of motion. As I already told, this momentum equation is based on the Newton's second law of motion, that is force equal to mass into acceleration. Okay, so every fluid particle having some initial force and its movement is some towards some direction with particular unit time. Okay, so here A is the acceleration acting on the same direction as force F. But what is in the acceleration? It is velocity divided by time. That means dv divided by dt. Okay, with respect velocity divided by with respect to time. So next, substitute this A value in this equation. So F is equal to m into dv divided by dt. Okay. So next, you take it into m into inside. Okay. So d is common and m into v divided by dt. So m is constant and can be taken inside the differential. M is constant and take it into inside the differential. Okay. So finally we get an answer. Force is equal to d into mb divided by dt. Okay, d into mb divided by dt. So this equation known as momentum principle. So again I am simplifying this equation. So dt goes to this side. Now tell me, what is the equation? So this equation can be written as F into dt equal to d into mb. Okay, which is known as the impulse momentum equation. And states that the impulse of your force F, acting on a fluid mass m, okay, in a short interval of time dt is equal to the change of momentum. Change of momentum. So m into mass into velocity is nothing but momentum. Please keep it in your mind. Mass into velocity is the momentum. So change of momentum in the direction of the force. So this is called a momentum equation. Okay. So this equation is called momentum principle, and this equation called impulse momentum equation. That is the difference. Okay. So the force acting on the fluid mass, okay, that mass of the fluid is m, means in a particular time, short interval of time, okay, that force which is equal to the uh, change of momentum in that direction of the force. That is the simple, okay, simple concept. This is the momentum equation. Okay, students, up to this second unit is over. Okay, second unit we successfully completed. Okay, students. So next we will move to the third unit.